Hello guys, so the weekly contest 434 has ended just few moments back, and in this weekly contest the first question asked was this: count partitions with even sum difference. In this problem what is given is an integer array, okay, and this integer array is nums of length n. Now this is what the parameter is given to us. Now there is this uh, definition about partition, and this partition is defined as an index I. Okay, partition is defined as an index I, which will which will be splitting the array into two non-empty subarrays such that the left subarray contains indices 0 to 1 and the right indices contains I plus 1 to n minus 1. N minus 1 is the last index. Then this is asking that return the number of partitions where the difference between the sum of the left and right subarrays is even. So we have to count the number of partitions where the difference between the sum of the left and the right subarrays is even. So how are we going to solve this? So the thing which comes to mind is that we create a prefix array. Okay, prefix sum array, new int, and for this we'll define one int n is equal to nums dot length, like this. Now we will define the prefix sum. So for prefix sum we can initialize the 0th index with the nums 0th index. Okay, so 0th index is already defined, so we'll start our traversal with the ith index, I minus 1 plus nums of I. So that way we will be accumulating at each index the sum of the all 0 to ith index values. So the total value from 0 to ith index. So this is how the prefix sum will be calculated, and the total sum will be prefix sum, of course, because the last index will be containing the total sum of the whole of the array. Now the question that is being asked to us is at from partition 1 int I is equal to 1 to I less than n. So I less than n will be n minus 1. We'll have to check if total sum minus, so total sum minus prefix sum of I and then prefix sum of I. Okay, why this is this is the right array sum, I plus 1 till n minus 1, this is that sum, and this is the left sum. Okay, this is this 0 till I. Okay, and we have to check whether this is an even number or not. So basically what we are doing, that we are doing this prefix sum into, so if this is even, then our value will be even. Now as we can see that this will always be even because we are multiplying it with 2. So evenness of this will depend on the evenness of this total sum. Why? Because we know that from an even number, if we subtract an even number, then we get back an even number. Okay, so evenness of this total, the value depends only on total sum. Okay, and this is a remarkable fact. Okay, so right now what we are doing, that we will be initializing one count variable. Okay, and if this is even, so to check how this is even, what we can do, we can do it like this, and 1 equal to 0. So we will put one more here, and then what we will do, we'll start one bracket, count, like this. But this is, we can do this, nothing wrong with this will be accepted as well. Okay, but entire p, sorry. So we can do this and this will be accepted as well, but it can be done in a better way. Why? Because we know that, while we are checking, we are, this part will always be even. Okay, and we also know that if you subtract an even number, this is an even number, and if you subtract an even number from an even number, then the result will always be even. So the evenness of this whole expression depends only on the evenness of this. So if total sum is even, then all values, the values will be equal to, the total partitions will be n minus 1. So it all depends on the total sum. So instead of doing all this, what we can do, that we remove all this. Okay, we don't even need this as well. We can just keep one sum variable, and sum is equal to 0. Okay, no need of this. And then sum plus nums of I, and we can initialize our loop traversal from 0th index. Why? Because 0th index value also will have to be taking, and then this sum will be having this value, and what will be returning, that return sum and 1 is equal to 0. Then if it is equal to 0, then we return n minus 1, otherwise we return 0. Okay, no required, so we'll have to remove all this. Okay, let's just run this. Perfect. So this is the way to solve this problem. I hope you liked the insight which goes behind this solution. So strictly because of the fact that if we are subtracting an even number out of an even number, okay, we are able to do this. So let's say sum is an even number, and we are subtracting an even number out of it. we will be getting back an even number. Okay, and we are for sure, we are sure that the number which we are subtracting from sum is an even number. So everything depends only on the sum value, and that's what we are doing. If sum and 1 is equal to 0, so if sum is even, then we return n minus 1, because that is the total number of partitions are possible. Otherwise we return 0. And that's what's the insight behind this solution. I hope you liked it. With this, I'm ending this video. Thanks a lot. Happy coding.